So this was a mock related to topic of the block 4 electricity magnetism from 4.1 to 4.6. In the first question, the diagram shows a small compass needle with the poles of a magnet marked. It is not near to the magnetic material. Diagram 2 shows a bar magnet that the poles are marked north and south. The compass needle is placed at point B. So what is the direction of a magnetic field? The direction of a magnetic field is always from north to south. So whenever we draw the magnetic field lines, so we draw the magnetic field lines out from north and into the south. So as a result, when we represent this magnetic field line, so it was from north to south. Now, the compass, whenever we place the compass needle always points in the direction of a magnetic field. So how the needle of the compass or the compass needle will point as we place here, as we place at this position P. So how the compass needle will point, it will point same as the direction of a magnetic field. So it will point towards the right hand side. That's why B is the right answer for this. In question 2, a student rubs the plastic rod with a cloth. The rod becomes positively charged. So there is a plastic rod and the student rubs the plastic rod with a cloth. So why the rod become positively charged and the cloth become negatively charged? So there's a transfer of the particle or transfer of electron. And how these electrons are transferred? So electron move from, because the metal become positive, so the rod become positive, so it means the rod loses electron. So what happened to the rod? The rod lose electron. When something lose electron, it will get a positive charge. Isolated metal sphere, which is a positively charged, is brought near to another isolated metal sphere that is neutral. So if we bring a positive charge rod, what will happen? One side will be negative and the other side will be positive. So it creates a distribution of the charge. So what happened to the charges as a neutral sphere, as a positively charged sphere is brought close to it? Remember, the positive charges never move. Why the positive charges never move? Because of their size. The positive charge never moves. So it cannot be A, it cannot be B, it cannot be C as well, because here's some positive move. So D is the correct answer, that positive charge do not move, but some of the negative charges actually what happen? They move or attracted towards the left hand side. So it creates a distribution of a charge. One side it is positive, the other side it is negative. In question 4, which statement about the resistance of a metal wire is correct? Resistance of a metal wire is directly proportional to length. So longer wires have high resistance than shorter wire, and resistance is inversely proportional to cross-sectional area. So thinner wires have high resistance than thicker wires. So resistance is directly proportional to its length and it is inversely proportional to area of cross-section. In question 5, the circuit diagram represents the LDR, the light dependent resistor, and the voltmeter are connected. Which row shows the resistance of LDR and the potential difference on the voltmeter at a specific light? So for a LDR, remember, light dependent resistor, when there is more light or if the light intensity increases, the resistance of LDR will decrease. It will have low resistance. So daytime, it will have low resistance, so the voltage will also decrease. Night, it will have high resistance, so voltage across LDR will also increase. So when it be daytime, like if a light level is bright, if we check the options, if the light level is bright, what about resistance of LDR will be low? If resistance of LDR is low, the voltage across LDR will also be low, so voltmeter reading should be low. So if it is bright, then the resistance of LDR will be low and the voltmeter reading should be low. So this is correct, this one is correct, but this is wrong. Bright, this is wrong. So then opposite, when we check, when the LDR at night, what will happen? The resistance of LDR will increase. As a result, when the resistance of LDR increases, what will happen? That the voltage across the LDR will also increase. So here resistance increase, so more voltage will be there, more voltage across the voltmeter as a result. So when it get dim or a dark, the resistance of LDR will be high. So resistance or a potential of LDR will also be high. So C is the right answer. Three NAND gates are connected on a single chip as shown. The whole chip behave like a single logic gate. So what is that logic gate? So you can make a truth table, like example, if input 1, input 2, and then the final output. So if input 1 is 0, input 2 is also 0. So this is a NAND gate. NAND gate, we get the result by multiplication and invert. So 0 multiplied by 0 is 0, passes to inverter, make it 1. And this also 0, 0 passes to inverter, make it 1. And 1, 1, it is 1, passes to inverter, will make it 0. So output will be 0. But if one of the input is high, like example, this is 1 and 0. So this will be 1, 1. This will be 0 and 0 multiplied. So this is 0, make it 1. So this will be 1, 0, 1 will be there. And same thing, when both are high, the output will be high. So what gate is this? It is actually acting like an OR gate. Question 7, a solenoid is connected to a sensitive ammeter. The rod is inverted. So what is this rod? Basically what we use a magnet, because when we move the magnet towards, or it can be done other way around. If you move the magnet towards or away, there will be a change in the magnetic field, and due to a change in magnetic field, it will induce or produce EMF. So what is this rod? This should be a permanent magnet or magnetized steel rod. Because with other material, it will not be a change in a magnetic field to induce EMF. In question 8, the diagram shows an electric generator with a coil in the vertical position. So this is a generator. When the generator is at a vertical position, the induced EMF is 0. When it is exactly horizontal, the induced EMF is maximum. So which rule describe a generator? Generator always produce an AC current here. So the generator produce AC and the voltage output is 0 when the coil is exactly vertical. So B is the right answer. If it is horizontal, then the voltage will be maximum voltage is produced by the generator. In question 9, the diagram shows a transformer. There are 460 turns in the primary and 224 turns in the secondary. Input voltage, that is 230. So that is 230. Remember, see, first thing, without calculation, you can identify, because it's a step down transformer. So the voltage should be less than 230. So this D cannot be an answer. So we are left with A, B, or C. And then we'll use a formula that this is VP, voltage of primary, VS, voltage of secondary, number of turns of primary, that is NP, number of turns of secondary, NS. So VS over VP equals NS over NP. So voltage of a secondary, we don't know. Voltage of a primary is 230. Number of turns of secondary are 424. And number of turns of the primary are 460. So when we cross multiply, it will be 24 times 230 divided by 460. So we simplify, this will be 2 and this 12. So B will be the right answer. Charge on a proton is E. What is the charge on electron and what is the charge? So proton is positive, electron is negative, so charge will be minus E. And then neutrons are neutral, so they don't have any charge. That's why D is the right answer. Uncharged metal sphere is placed on an insulating support. The positive charge rod is brought closer but does not touch. So remember, negative charges only move. So one side will be negative. As the negative charges move, so one side it creates positive. One side will be negative, one side will be positive. So the charges, the negative charge move towards the right hand side, but overall sphere, because it only creates a distribution of the charge, left hand side is positive and the right hand side is negative, but overall, like if plus 3 positive, 3 negative, the net charge is 0. So that's why the negative charges move towards the right hand side, but the sphere overall will remain neutral until unless we connect an earthing wire and remove the charge by using the earthing wire, or enter the charge by using the earthing wire. In question 12, which circuit in which circuit is the ammeter measured the flow of the charge through the lamp? So ammeter should always connected in series. So this is the wrong position. This is the right position. This is wrong as well. And here also this is wrong. So C, B is the right answer because ammeters are always connected in series, where voltmeter are always connected in parallel. The lamps are connected to a cell. Which circuit diagram shows the direction of conventional current? So conventional current is out from positive and into negative. And electron flow is from negative to positive. So when we check, this is positive, negative. So conventional current from positive to negative, but here direction of conventional current is not correct. When we check from positive to negative, so direction of conventional current is not correct as well, because it is given other way around, shown other way around. When we check, this is positive, negative, so direction of the conventional current, so that is correct. And when we check electron flow is from negative to positive. So if the electrons were there moving in this manner, so they will flow, so that is also correct. So conventional current and the electron flow, both directions are shown correctly. So C is the right answer. The diagram shows a circuit containing two resistors, 1 ohm and 2 ohm. A voltmeter is connected across a 2 ohm resistor by connecting from P to X. The reading on the voltmeter is 6. P is moved to point Y in the circuit. What is the new reading of the voltmeter? Look how we can work out, because look, they are connected, they are in series. Whenever they are in series, the total voltage will be same. So when P is connected to X, here is a 6 volts. So how much is the current? We have the formula V is equals to IR. Voltage is equals to current multiplied by resistance. And you can also solve by using a concept, the ratio of the voltage is same as the ratio of the resistance. So how the voltage divides, same resistance will be also be divided, or resistance divides, same voltage will be divided. So ratio of the resistance is 1:2. So ratio of the voltage will also be 1:2. So if here is 6 volts, how much voltage will be here? 12 volt. So what is the total voltage now? Because one side we have 6 volts, the other side we have 12 volt. So when we connect this part P to Y, so what will be the reading on the voltmeter? The reading on the voltmeter will be 12, because 6 volts here and 12 volts here. So the total reading will be 12. Or you can solve, there's another way you can use that method. First, find the current here. You have the formula V is equals to IR. So V is the voltage, which is 6. I is the current, we don't know. And R is the resistance 1. So 1 is divided there. So we'll get 6 ampere as a current. So 6 ampere is a current which is moving through 1 ohm. and 6 ampere will flow through the 2 ohm. So we have the current, we have the resistance. So we'll use the formula V equals IR. So current is 6 and the resistance is 2. So the voltage will be 12. So one side voltage is 12 and the other side voltage is 6. So what is the total voltage of this circuit? That is equals to 6 plus 12, which is 18 volts. So D will be the right answer. In question 15, the graph shows the current and voltage relationship for component X. Current and voltage resistance. So remember, whenever current voltage is there, the slope is reciprocal of R, 1 over R. So what is happening here? The slope is increasing. If a slope is increasing, it means the resistance is decreasing. And what is the relation between whenever we are using a component, like any component, with the passage of a time, as a current increase, because if more current is there, the more particle collision or more lattice vibration. So temperature always increases with the current. More current means more temperature. So when we check the temperature value, because the current is increasing, so the temperature should also increase. So the answer with the temperature increasing can be B or D. Then what about the resistance? Because the current and voltage graph, the slope represents the resistance. So as the slope is increasing, the resistance is decreasing. So it matches with option B. So actually this component is a thermistor, for which when we increase the temperature, the resistance decreases. The diagram shows a pair of a circuit containing a logic gate. In which diagram does the lower pair in which diagram does the lower circuit of a pair behave differently from the upper? So if this is 0, this will be 1. This is 0, 0, 0 is 0, passes through inverter, will make it 1. 0 into 0 is 0, passes through inverter, make it 1. So they are acting same. If this is 1 and 0, so 1, 0, this is 0. But this is 1 and 0. 1 multiplied by 0 is 0, passes through inverter, make it 1. And 1 multiplied by 1 is 1, passes through inverter, make it 0. So it is, both are acting in the same way. When we check this one, if it is 1 and 0, so 1 and 0, it will be 1, and this is 1 and 0. So this will be 1, passes through inverter, make it 0, and 0 into 0, make it 0, passes through inverter, make it 1. So both are acting in the same way. But when we check this one, example 1 and 1, passes through inverter, make it, passes through AND gate, make it 1. Here 1 and 1, 1 plus 1, or if this was 1 and 0, this will make it 0, and this is 1 and 0. 1 plus 0 is 1, passes through inverter, make it 0, and 0 passes through inverter, make it 1. So upper circuit and the lower circuit are not behaving in the same manner. That's why D is the right answer. In which circuit do the both lamps light? So we have a diode. Diode allow the current to flow only in one direction. So when the current is coming from the side of the plate, allow, but when it is from opposite side, the diode will block, does not allow the current to pass through. So conventional current, so current, even it is blocked here, so this lamp will be off. This will also be off. So here also the diode will block the current. So the circuit is incomplete. Circuit is not complete. What will happen? The both lamps will be off. But when for this one, conventional current, it passes through the first one and as well as the second one. So diode is allowing the current to flow. So this lamp will be on. The other one is also on. What about D? The lamp in the center will be on, but the other lamp, because it is not, the circuit is not complete, so this will be off. The middle lamp will be on. Two resistors are connected in parallel. Whenever two resistors are connected in parallel, the formula, the combined resistance is the product divided by sum. So to understand this, you can take any value. Like example, I took 10 and 10. So what is the combined resistance of these? That is, when two resistors are there, we can use the product divided by sum to get the combined resistance. So the product is 10 multiplied by 10. The sum is 10 plus 10. So 100 divided by 20. So that is equals to 5. So the combined resistance is coming out less. The combined resistance is always coming out less than R1 and R2. That's why A is the right answer. So whenever two resistors are connected in parallel, the combined resistance is always less than the smallest one in a combination. And when they are in series, the combined resistance is always greater than the highest one or the larger one in the combination. The metal case of electrical appliances are connected to earth. Which statement is not correct? What is the purpose of the earthing wire? Earthing wire is mainly used for the safety of the person, the operator. The live wire may become loose and touch the metal case. That is a possibility. If the metal case become live, the earthing wire conduct the current to the ground. That's also true. Like what happened? So this is the appliance, say electrical heater is there, and we have the live wire, orange example representing a live wire and blue is representing a neutral wire. So what happened in case if there is a live wire is in contact with the metal body, so if the earthing wire, the extra current, if there is, that earthing wire will remove that current out from the body. The earthing wire need to have a high resistance. That is wrong. Because we want earthing wire to remove all the current out from the circuit. So if earthing wire, we want the current to remove out from the circuit, so earthing wire should have a low resistance. So when it is having a low resistance, so most of the current will pass through the earthing wire. In case if a person is in contact with a metal body, he will not get an electric shock. Otherwise, if earthing wire is having a high resistance, then most of the current will pass through the operator, the person who's operating a device or an appliance, and more likely he will receive an electric shock. When earthing wire is having a low resistance, there is a possibility that the current will pass through an operator, but it will be a mild shock. It will not cause too much damage. An earthing metal case helps to prevent a person from receiving electric shock. That's also true. What is the function of a split rings commutator in a DC motor? So what happened? What is the purpose of the split ring commutators, or which we call carbon brushes and commutators are there? So they reverse the current in the coil and its plane become perpendicular to a magnetic field. What does it mean? Like example, here when we check the options to enable motor to function as an AC source, that is wrong. To reverse the current in a coil once every revolution, not every revolution, every half revolution. Like what does it mean every half revolution? Say we have a DC motor, this is a north pole, here is a south pole, and we have a rectangular coil placed. The rectangular coil is placed A, B, C, and D. So when it rotates 180 degrees or a half rotation is there, say the current or the direction of a current first from A to B and then C to D. When it rotated half or 180 degrees, now the positions will change. CD will be there on the left hand side and AB will be there on the right hand side. So this will be CD and there will be A and B. Now what is the direction of a current? C and D is up and B and D is down. So direction of the current is reverses, but what in terms of rotation, how much is this rotation? This is 180 degree rotation. So it's not like every revolution, it is every half revolution. So to reverse the direction of, to reverse the current in the coil, whenever its plane becomes perpendicular to the magnetic field, like when it is exactly perpendicular 90 degree to magnetic field, it reverses the current. When it is vertical, there is no contact between the split rings and the carbon brushes, so there is no current. So C is the right answer. Which graph represent an alternating current or AC? AC current means the current which changes the direction, or for how we represent an AC current by using the both axes, the positive and the negative, both axes. So here we are using a positive axis, positive y-axis and negative y-axis, which shows the direction of the current has changed. So A is the right answer. Why not B? B, we are using only the positive axis. We are not using a negative axis. So that's why B is not an AC. B is actually a direct current or DC. What about C? C also we are using only one part of an axis, positive Y. So that's why it is also DC. What about D? We are using the negative axis. We are not using a positive axis. So only one axis is used. That's why D is also our DC. So AC means to represent in alternating current, how we represent, we should use both axes. Like example, if option D was an AC current, we should represent how? We should represent in this manner, in which we will use both of the axes, like the positive as well as negative. This will be AC. But because we are using only the one part of an axis, that's why B, C, and D options are representing a DC current. The diagram shows a horizontal wire in a magnetic field. The horizontal wire is firmly held at each end, not shown and cannot be moved. The magnets and the holder are on the balance. When there is no current, the reading on the balance is 0.35 gram. When there is a DC current or a direct current, what happened to the reading on the balance? So how to identify what will happen to the reading on the balance? What you have to do, you have to first identify the direction of the force. How to identify the direction of the force? So what we will do, we will use, to find the direction of the force, we'll use Fleming's left hand. And according to Fleming's left hand rule, your index finger or the first finger represent the magnetic south. Your second finger will represent the direction of the current or the direction of a conventional current, and your thumb will represent the direction of the force. So which direction it experiences the force, the wire experiences the force, that will give us, that will be given by our thumb. So when we apply the rule, when you apply the rule, your index finger should point towards the south. So your index finger, according to this, your index finger will point on toward the right hand side. So you use your left hand, your index finger should point toward the right hand side. Your second finger represents the direction of the current. When you're looking this, I'm applying a rule on this diagram. So my second finger should point downward. Where my thumb is pointing out of the screen, or when we look from the above, it is pointing towards us, or when we look from sideways, so it will, the force on the wire will be upward. So when force is upward, because basically what happened, there is a magnetic field of a magnet and there is a magnetic field of a wire. Because when a current carrying conductor is there, the current carrying conductor is also applying a producing a magnetic field, and two magnetic fields interact with each other. So if two magnetic fields interact with each other, if the wire is pushed by the magnet upward, what will happen? It means the wire will repel the magnet downward. Because what is happening, like if two poles of a magnet are there, if they're identical poles, they will repel each other. So if the wire is being pushed up, the magnet will be pushed down to balance it, to repel it. So as a result, already 0.35 gram is there, but there is also another downward force. So whenever there is another downward force, as a result, what will happen? The reading on the balance will increase. So already some mass is there, and now when there is a current in the wire, produce a magnetic field which interact with the magnetic field of a permanent magnet. So if the wire is experiencing an upward force, the magnet will experience a downward force, because in opposite direction, either they will attract each other or repel each other. So right now, according to this, if the wire is pushed away, the magnet will also be pushed away. That's why the magnet will push downward if the wire is pushed up. So as a result, there is also an extra downward force. So what will happen? The reading on the balance will increase. If there was the same question, but what will happen if the direction of the current was opposite? Like right now, the current is going according to this figure downward. Say the current was upward. So what will the direction of the force? So the direction of the force on the wire will be, when we apply the rule, the direction of the force will be into, or we can say downward. So now the wire is being attracted by the magnet towards the magnet. So magnet will be attracted towards the wire. So in that case, what will happen? The reading on the balance will decrease because there is a weight acting downward and there's an upward force is there. So weight is acting downward and upward force attraction from the wire, the magnetic field interaction, there's attraction. So as a result, the total downward force will decrease. So in that case, the reading will decrease. But here, according to this direction, if the wire is being pushed away, the magnet is also pushed away, but you can see the balance reading because the direction of the force which is pushing the magnet away is same as the direction of the weight. So as a result, more downward force. So that will be D. A 12-volt battery is connected to a 24-watt lamp and a parallel pair of identical resistor. A 24-watt lamp with a normal brightness is there. It is 6 volts. So calculate the lamp is at normal brightness. Calculate the resistance. So how we can calculate the resistance? First, we have the power of the lamp and we have the voltage, which is 6 here. So we have the formula P is equals to VI. So power is 24, voltage is 6, and current we don't know. So it will be 24 divided by 6. So the current is equals to 4 amps. Now we know the current and we can use the formula. Resistance is the ratio between voltage and current. So voltage is 6 and the current is 4. So 6 divided by 4, that's equal to 1.5 ohm. So 1.5 ohms is the resistance. Then what is the potential or a voltage across AB? If the total is 12 and out of 12, 6 volts is here. So how much voltage? Remaining 6 volts will be there across AB. Then the combined resistance of parallel combination, the combined resistance of a parallel pair of identical resistor. So how we can find? Because the voltage divide evenly, if the resistance, when we calculated the resistance of this part, if it was coming out as 1.5, so what about the resistance of the other part? The resistance of the other part should also be 1. They should have the identical resistance, because if they have the identical resistance, the voltage will divide evenly. So that should also be 1.5. So if 6 volts is here, this part was having 6 volts, this is also having 6. So if the voltage divide evenly, the resistance will be even. So if this was 1.5 ohm, the resistance of the combined resistance of these two will also be 1.5 ohm. So without calculation, it's a 1 mark. So you just have to write a direct answer without showing any formula or working. Then we need the resistance of X. And they mentioned that a pair of identical resistors. So these two are identical resistors. X and Y have same resistance. So if I say resistance of X is R, resistance of Y is also R. So the combined resistance is the product divided by sum. So the total resistance of this part is 1.5. So that is 1.5. The combined, this is R, R1 is R, multiplied by R2 is also R, divided by R1 plus R2. So 1.5 is equals to R square divided by 2R. Square will cancel with R. So 2 is divided, other side will be multiplied. So 1.5 into 2, that's the total resistance is equals to the resistance of individual or each is equals to 3 ohm. The answer here, that the resistance of X was actually 3 ohms. Question 24 is related to transformer. There are 200 turns in the primary and 340 turns in the secondary. So 4 volts is applied in P. So this we apply 4 volts here. This is a step-up transformer. Explain why there's a voltage between the two terminals of coil Q. So you have to explain the working. You have to learn this like AC input in the primary. Here they mention coil, so you can mention AC input in coil P produce variable magnetic field or changing magnetic field. And as a result of variable change in magnetic field, it will magnetize the iron core. And as a result, the change in magnetic field of iron core produce EMF in secondary coil. So that's how this works. That AC input produce variable magnetic field, change in magnetic field, and that change in magnetic field induce EMF in the secondary coil. Explain why the core of a transformer is made from soft iron. Because iron can be magnetized and demagnetized easily. Why it was not steel? Because it is difficult to magnetize. So the answer here, because it can be magnetized or demagnetized easily. Calculate the voltage between the two terminals of coil Q. So how we can calculate? So this one is the number of turns of primary NP, the number of turns of secondary NS, voltage of the primary, that is VP, it is equals to 4, and VS we need. So the formula, the voltage of a secondary VS over VP equals NS over NP. So VS is 4. VS is unknown, VP is 4. Number of turns of secondary are 340 divided by numbers from 200. So this 4 is divided, other side it will be multiplied there. So it will be 340 multiplied by 4 divided by 200. That will give us the voltage produced in the secondary, which is about 6.8. So this will be 6.8 volts. And the transformer, if it is 100% efficient, the power input and power output will be same. So VP IP equals VS IS. So this was 4. Current in the heater is connected. So this is the output current. This is IS, which is 3.5. Voltage of a secondary we calculated, that was 6.8. And IP is the current in the primary coil, which is about 6 or 5.95 or about 6 ampere. Then a transformer is used to step up the voltage before electrical. So one advantage, it reduces the power loss in the form of heat and reduce the cost of making these wires.